In section 1.4, we will discuss applications of equations. If you would like to follow along, section 1.4 starts on page 24 in your textbook. Our goals for this lesson are to be able to translate words into mathematical expressions or story problems, translate word sentences into equations, and use these equations to solve problems. There is a language of algebra that provides us a powerful way to translate word expressions into algebraic or mathematical expressions. Variables are used to represent numbers that are not known. We can use any letter to represent a variable. If we say we have a number increased by 5, an algebraic expression to represent this verbal expression could be n plus 5. Twice the cube of a number would be 2n cubed. 3 times the sum of a number and 7 could be written as 3 times the quantity of n plus 7. In the same way, equations can be used to represent verbal mathematical sentences. An equation to represent this sentence, a number decreased by 7 is -3, would be n minus 7 equals -3. The sentence, a number divided by 3 is equal to 3 over 4, can be written as the equation n over 3 equals 3 over 4. For our first story problem example, the Conte family is planning to put a railing around the deck in their backyard. The deck is 2 pieces, a square and an equilateral triangle, which share a common side. They will buy 75 feet of railing to go around the outside of the deck. How long should they cut the pieces so there is 1 piece for each side of the deck? In solving story problems, we want to use 4 problem-solving steps. The first step is to explore the problem. For this problem, we will explore the problem and choose a variable to represent the unknown number. The problem asks us to find the length of each side. So let's say that S equals the length of each side. Next, we want to plan the solution. In planning the solution, we want to write an equation that represents the relationship in the problem. The diagram shown may be helpful. The perimeter is 5 times the length of one side, so we know that 5s has to equal 75. Our third step is to solve the equation. In solving the equation, we see that the length of one side is 15 feet. The last step in solving a story problem is to examine the solution. We will check our solution against the words of the problem and the diagram we drew. Since there are 5 equal sides that make up the perimeter of the deck and 5 times 15 equals 75, our solution is correct. In our next example, a number increased by 17 is 41. Let's explore the problem. We will let n stand for a number. In planning our solution, let's write an equation. N increased by 17 equals 41. In solving our solution, we find that n equals 24, so our number is 24. To examine our solution, we can ask ourselves, does 24 increased by 17 equal 41? So yes, 41 does equal 41, so our solution is correct. Next, let's explore how we can use these verbal instructions to form an equation. We will use n for a number. Next, we will add 10 to that number. Then, we follow step 3 and divide by 5, decrease or subtract 5, And lastly, multiply by 2. So what we have is an equation that for any real number n, substituted and following these 5 steps will be true. So if you think of a number and follow steps 1 through 5, you should get the same answer if you think of the same number and substitute for n in this equation. So to recap, the 4 steps in solving problems are to 1. Explore the problem, 2. Plan the solution, 3. Solve the problem, and 4. Examine the solution for correctness. In the assigned homework, you will be asked to show all 4 steps for complete credit. Please come to class prepared to work on the assigned problems.